Okay, we're going to be talking about domain of a rational function. This is a rational function because it's a fraction. Remember that you can never divide by 0, so that does cause a domain restriction here. We can't ever have this bottom go to 0. However, in this case, we do need to be aware of the fact that the top of this factors into x minus 3, x plus 3. It doesn't change the fact that there's a domain restriction because we still don't need that bottom to go to 0. However, it does change the type of domain restriction it is. Because I have an x minus 3 on top and an x minus 3 on bottom, this creates a hole as opposed to a vertical asymptote. But either way, x minus 3 cannot equal 0, so x cannot be 3. In this case, it's a hole. Now on B, when I factor the bottom, there's actually two things this bottom cannot be, x minus 3 or x plus 3. Because there's nothing on top the same as on bottom, I have no holes in this case, I have two vertical asymptotes. X minus 3 cannot be 0, and x plus 3 cannot be 0, because you can never divide by 0. So x equals 3, and x equals negative 3, and these are both vertical asymptotes. It can happen where you'll have one hole and one vertical asymptote. For example, if I had a function like this, in this case the bottom factors is x minus 5x plus 5. This creates a hole and this creates an asymptote. So I have x minus 5 cannot be 0. X plus 5 cannot be 0, x cannot be 5, and x cannot be negative 5. This one is a hole, and this one is a vertical asymptote. One other thing you need to consider in this case, if you have a rational function that has an x squared plus something on the bottom, these have no domain restriction. And that's because x squared plus 9 cannot equal 0 would give me x squared cannot be negative 9. And in fact, x squared can never be negative 9 because when you square a number, it always becomes positive. So these have no domain restriction.